Today, I'm so excited to share with you my favorite topic, which is, of course, digital dentures. But before we go to 2025, let's roll it way back to 1937. That was the year the Hindenburg exploded, the year Amelia Earhart took her infamous flight, FDR was president, and we began press packing polymethyl methacrylate dentures. And truly, this method of denture fabrication reigned supreme for nearly 100 years. And we just started to see kind of this revolution and changing and moving forward very recently. Um, we've been doing digital dentistry for quite a while. I know it's hard to believe, but Sarek turned 40 this year. So I am officially older than Sarek, although most of my dental students are not. I learned on this middle Sarek here. And so we've been really working with digital dentistry for a long time and seeing the evolution become more and more predictable and the materials, of course, becoming more and more efficient and strong and what we expect to see for our patients, high quality. Even digital dentures have been around since the 1990s. This is the proof of concept paper, so they were not commercially available yet, but certainly the idea was starting as early as 1994. And again, this was kind of the first proof of concept paper. It was something that was not really scalable. And again, as things have evolved and things have improved, we've started to see a bigger uptake. I always make my students read this manuscript. I call it now Classic Literature from 2012. And this was the first paper that really showed what we can do as private practice clinicians. So this was the first time that digital dentures became commercially available in 2012. And there were two different companies that were working with this. One was Avident, which kind of pioneered that milled denture workflow, and the other was Dentka, who is pioneering the printed denture workflow. So that's my quick history lesson in digital dentures. And I like to show this, especially to my students. If you look on the left, this is Yeezy making a denture in the 1920s. A lot of these torture-looking device instruments are very similar to what I learned on in dental school in prosthodontics, where we're establishing our central bearing pin with Gothic arch tracing and doing ear bow tracings. And if you look at the video on the right, this is one of the first digital dentures that I ever did. This is one of my patients from 2012. So what I love is when you do a side-by-side comparison to what we were teaching and doing and practicing in the 1920s compared to 2012, you can start to see how this all evolved. And to show you a little bit of my geeky side, the reason why I became interested in digital dentures and why I embraced this was when I saw the Gothic arch tracing being digitized. And so taking all these foundational elements that are in the classic literature that we read as prosthodontists and in the textbooks that have been edited and published and reinforced over many, many decades, those concepts are what really pushed the evolution of digital. So it's not something new, it's not something untested, it's something that took what we know, took the foundation, and then turned it around to make it more predictable in the hands of both clinicians and technicians. So to show how we got from 2012 without those two workflows to where we are today, we had so many improvements so quickly. So in 2015 was when we first saw the FDA clearance of printed resins for intraoral use. So we've now been seeing these in the mouth for over 10 years. We had many open source workflows in 2017. And to me, this was the key that kind of switched us from these very locked down workflows to something that everyone can embrace today. Because when I first started teaching digital dentistry back in the early 2010s, everything was locked down. This scanner only worked with this mill, or this resin only works with this printer. And so everything really started opening up in 2017 with a lot of these softwares like Exicad and Blue Sky Bio, Blender for Dental, and all these things that let you say, okay, I can design here and I can put it on any printer or any mill that I want. And then the scanner companies followed suit, where now you can take an STL from a scanner and export it to anything you want. So that really opened up so many workflows for technicians and clinicians, and we really saw this boom in production and what we're able to do. And last but not least, in 2019 is when we started to see the high impact printed resins. So with all these changes to hardware, software, materials, workflows, today you can really do anything you want. You can make a denture with any sort of material, any sort of workflow, follow in and out and weave these things together, which I think is super exciting. But if you're not familiar with both the conventional and the digital workflow, it can make it hard to know where to start and how to kind of embrace this. So let's start at the beginning with digital denture workflows. Any digital dentistry, whether it's a crown, a night guard, a denture, every digital dentistry workflow has a step that falls into one of three categories. You're either acquiring data, so a scan, a photo, an x-ray, an impression, an interocclusal record. You're designing something, so you're taking all of that data and putting it into design software. That's the CAD part of CAD/CAM, so computer aided design is step two. And then you're taking that design and making something physical, which is fabrication, or the CAM part of CAD/CAM, which is computer aided manufacturing. So with the denture world, that might look something like this. We're acquiring data, getting a good final impression, getting a good interocclusal record, getting our patient shade and photo, pulling all of that into the design software where we can do our virtual tooth arrangement, and then ultimately fabricating either a provisional or a final denture. I won't stay on this slide long. I teach the denture class to the second year dental students, and I took the denture class many times, so I know this can induce PTSD with a 5 appointment workflow, but this is what truly has been taught since the 1920s. And nothing really changed over time. We actually do still teach this side by side with the digital workflows, along with pretty much every dental school in the country. So here is kind of how we're switching from the conventional to the digital world. So everything is still there. It's just condensed. So we're not skipping any steps. We're not skipping any data. All the fundamentals are still important, but we're combining some of those together. So typically we're taking that jaw relation record or maxillomandibular relation record, whatever you might call it, and combining it either with phase one, which is the impressions, or combining it with phase two at the try-in. The average workflow is 2.38 visits. So we're going to share today some 2, 3, and 4 appointment workflows. So you can start to see how those might align. And it's going to vary from provider to provider and from patient to patient, which one of these workflows you'll choose. So again, typically we'll take those records, the jaw relation records, and combine it with an impression. And these are 2 sample workflows. We'll go through the wax rim workflow today that you see on the top. The bottom image is a proprietary workflow from Dentka. Or you can combine it with a try-in. And so this is showing the reference denture workflow that we'll spend a lot of time with in this presentation, as well as a Wagner workflow. So let's start at the step 1, which is impressions. You can't make anything in prosthodontics without a great impression. You can't do a crown, an implant, denture, all in X, whatever you're doing, you have to start with impressions. And you can see for digital dentures, we have a lot of samples across the top here. We have alginates, we have PVS, and we have scans. And you can use any of these impressions to get started with your digital denture workflow. And I think that's one of the key concepts to understand as we go throughout is that you don't have to start with a scan. And truly, even today in 2025, the majority of digital denture workflows still start with a conventional impression. And I think that bears repeating because truly that's one of the biggest misconceptions I get from students, from patients, from clinicians is that it's hard to scan soft tissue. How do I get into the digital denture world? And so I feel like once you can kind of break through that barrier, understanding that you can start with that conventional impression technique, it will help illuminate the rest of the steps. And the way we jump from the conventional world to the digital world is by scanning that impression or a cast if you start with an alginate or if they come in with a cast already. And the key, I say this is the key to the kingdom, is digitizing those records. And there are many different ways to do this. You can start most commonly with a benchtop scanner. And so this is kind of the gold standard of record digitizing. It's utilizing a tabletop scanner. The great news is most clinicians don't have these in their in-house. So if you don't have one, you're normal. If you do have one, you're lucky. But the great news is most dental laboratories do have this type of scanner in-house. So whenever you send a conventional record to your dental laboratory, more often than not, they're putting them in a benchtop or a tabletop scanner, digitizing those and maintaining that record for you. You can also use an intraoral scanner and scan your physical records. So if you have a patient that comes in with a denture, or if you take a nice impression, you can actually use your intraoral scanner, scan that, and export that STL. More recently, there have been workflows where you can utilize a CBCT and actually put your prosthesis in the CT scanner and digitize it that way. This is a little bit more novel, and there's still kind of data looking at what are the indications and contraindications for this. The one that we have here is a CareStream, and that will automatically output an STL. So you're not actually changing, like exporting a DICOM and flipping it over. It exports an STL. So no matter if you're doing an intraoral scanner, a benchtop scanner, or a CBCT scan, you're ending up in the same point with this STL file of your patient. You still can use your intraoral scanner and scan soft tissue. So if you prefer this workflow, this has been validated as well. The image you're seeing here is from 3Shape, and so this is utilizing their Trio scanner. Lucia LaRusso has done a ton of work on the accuracy and techniques for doing this. And if you see here, this is the scan pattern that he found with 3Shape was resulting in the most accurate impression. So if you're having trouble scanning and you're not getting stitched together right, here's a QR code to, it's a free article on the 3Shape site. They're not a sponsor. I do not speak for 3Shape. But if you take this, it's a really, really nice article, and it's all in color. I love anything with color photos, and I really love anything that's free. So again, this will kind of walk through how you do the scan pattern to try to achieve the most accuracy with your intraoral soft tissue scans. But no matter how you achieve your impression, whether it's an intraoral scan, whether it's a benchtop scan or an impression, you really, really need to make sure you're capturing all those anatomic landmarks. So no matter if it's a conventional denture, digital denture, no matter the workflow, make sure when you take that impression, you can see your patient's limiting structures, supporting structures, or tuberosity, incisive papilla. The software needs all those landmarks in order to output a denture that's going to fit and serve your patient well. So the workflows that we walk through are mostly going to be showing starting with an impression. There are a number of workflows that you can follow where you can start with a scan and then jump into either a digital or a conventional workflow and go back and forth, or you can stay digital all the way through. So once you've gotten your scan, you've started getting your records, the next big step in the sequence is going to be what we call the trial denture. And it can be any sort of trial denture that you want. Again, I love the versatility of the workflows. If you look at the conventional world on the right, we have a wax tooth setup. You can actually go to a conventional wax tooth setup, scan that in, and either finalize that way or preserve that wax tooth try-in digitally. That's a pretty cumbersome workflow that most people don't follow, but I like to show it because truly you can do literally anything you want with digital dentistry. On the left, you'll see the monolithic try-in. As we go through this presentation, I'm going to be focusing a lot on the monolithic try-in. I am a personal believer that this is going to be the future of all denture workflows. I'll be surprised if 20 years from now we still have a wax option at most dental labs. And a lot of dental laboratories I've been working with are eliminating wax from their protocol because it's so much easier, more efficient, and you have preservation of records with a monolithic try-in. In the middle here, we have the Wagner try-in. I'm showing this more as kind of an educational piece. We have a lot of classically trained prosthodontists here at UNC, but we really wanted to get the digital workflow going on board. So we introduced this middle option so that we can still teach students how to move teeth and wax, but capitalize on the benefits of some digital denture properties. So with a Wagner try-in, you have teeth individually set in wax on the maxillary. You have wax rims on the mandibular, so you can do conventional methods for jaw relation records, as well as vertical dimension of occlusion and tooth arrangement. So again, monolithic trial denture, to me, this is the future of dentures. I spend a lot of time on this with my students in class. It's nice because it can be printed on any printer. So if you're running tight with on your patient schedule and you need to get this tried in quickly, you can have your lab actually send you an STL and you can quickly print this in-house and go right to your patient. Um, but if you utilize an FDA cleared resin, an FDA cleared try-in resin, your patient can actually wear this home. And that unlocks a whole new array of possibilities for your patient. Because if you think about one of the most frustrating things I have with wax tooth try-ins is we put it in, we ask the patient to look at it for 10 minutes and say, okay, what do you think? Sign here, let's go to final. But they haven't had a chance to actually eat with it or speak with it because there's wax in the way, or they haven't gotten to take it home and show their friends and family. So your patient can actually wear this monolithic trial denture home, try it out, and truly take it for a test drive. It's like a prototype for an All-on-X, but you're doing a prototype for your denture. And so to me, this helps take dentures to the next level as you start really homing in on aesthetics, phonetics, and function. This is just showing in that Wagner trying a little bit more up close. This is not always the most cost-efficient workflow to utilize as a clinician, but I think it's a fantastic teaching tool and kind of, I call it the gateway digital denture as you go from the conventional world to the digital world. And then last but not least, again, we have the conventional wax tooth setup. This is the most cost intensive from both financial side as well as time. Um, Prosthodontists really like this because again, we can move all the teeth individually. But I think once you overcome that hurdle and really learn to work with a monolithic trial denture, there's a lot of ways where you can still get that same satisfaction of getting the teeth exactly where you want them. And I like to show this also because when you think about a wax tooth setup, one of the great things about it is these are the final denture teeth. So the patient really gets to see the final shape and shade of the teeth that are going to be in the definitive denture. But the downside is these are the final denture teeth. And so if the occlusion is incorrect, you have the option of moving all the teeth chair side or sending it back to the lab to do another tooth arrangement because you can't grind on these the way you can grind on a monolithic denture. So I think that's one of the biggest hurdles to overcome as a clinician. If you haven't worked a lot with a monolithic trial denture, we've had this ingrained in us in dental school that you can't grind on these denture teeth. And so it kind of pains us to start grinding on the monolithic try-in because we have to get through that paradigm shift. So just remember that the monolithic try-in has some properties that are kind of like a clinical try-in and some properties that are like a wax rim. So no matter which try-in you choose, it doesn't matter if it's the fully printed or fully in wax, you have the same goals. You want to establish a patient's aesthetics, establish a patient's occlusal relationship, and move forward so you can start to find where those denture teeth are supposed to be. So we have these three records that we need to achieve to send to our dental laboratories, which will be the vertical record, which we sometimes call the vertical dimension of occlusion. So that's how tall should the dentures be? What's the space between the maxilla and the mandible? You have the horizontal record, which is what we call our interocclusal record. And there are several different types. So you can do MIP, you can do CR, you can do neuromuscular. Most of the time with dentures, we're going to live in the centric relation world. If you think about occlusion, there's three things that determine your occlusal position. One is your jaw joint, one is your muscles, and one is your teeth. When you have a denture patient, you don't have teeth. So you've already eliminated that variable. So you can rely on either the jaw joint or the muscles. The muscles don't usually have a repeatable position. If you're sitting up, they go one way. If you're laying down, they go one way. If you're stressed, they go one way. If you're relaxed, they go one way. So we like to rely on our TMJ or our jaw joint to kind of give us that horizontal position of where the mandible should be in relationship to the maxilla. So that's why dentures, we live in the centric relation world. So typically we'll get a vertical dimension of rest, a vertical dimension of occlusion. We'll get a centric relation record, and we'll get an orientation record. Now, in the conventional world, this orientation record is your face bow or your ear bow. There are very fancy ways where you can try to do a face bow and transfer that data into the digital realm. However, typically our orientation record for digital dentures is going to be a full face photograph. So we'll show that as we go through cases. You want to take a photo of your patient facing forward. You want to see their eyes and you want to see their ears. So you don't want your patient to turn to this side or this side. You want them looking straight at you so that you can orient that intraoral scan with your patient's photo. And once you get through the trial denture, establish all those records, now we're finally ready to fabricate our dentures. So with CAM, or computer aided manufacturing, there are two categories. One of those is going to be milling, which is subtractive, and the other is going to be printing, which is additive. And so typically you'll hear milling referred to as subtractive manufacturing and printing referred to as additive manufacturing. So whenever you hear somebody use those, they're often interchangeable. So subtractive manufacturing is milling, additive manufacturing is printing. And we call it subtractive manufacturing because you're starting with some sort of material. For dentures, it's going to be polymethyl methacrylate. For a crown, it might be Emax or zirconia. You're starting with a block or a puck of that, and then you're subtracting away the extra material to get your final prosthesis. So I always like to say that milled dentures are like when Michelangelo chiseled David out of marble, and each denture is a little work of art. The one thing that I think is important to note here, that milled dentures or dentures fabricated with subtractive manufacturing techniques are made of PMMA, which is also called polymethyl methacrylate. And if you remember one of my very first slides where I showed conventionally processed dentures, we were utilizing PMMA or polymethyl methacrylate in 1937 to make our conventional dentures. And what that means is the milled dentures that we make today in 2025 are actually the same exact chemical compound that we've been using for nearly 100 years. So again, everything is new and the way that we make it is new, the workflows are new, but the materials are not necessarily brand new. So this is a material that's time tested. We've been using it literally for a century, but now we found a way to make it better. And we make it better by pre-polymerizing it. And what that means is when we make a denture, normally with the press pack that I showed you, we're investing, we're moving things around, we're packing it, we're going in many layers, and every one of those steps introduces a little bit of error. The most significant of those is what we call polymerization error. So while your denture is being made, the material is actually contracting away from the master cast. So there's always error introduced when you process a denture conventionally. When you mill a denture, that error is already gone. So the mill is using this pre-polymerized resin to create a true one-to-one fit against the tissue. So the best fit we can get with a PMMA denture is going to be subtractive manufacturing. And this photo, sorry, let me go back one more. You're seeing a monolithic milled denture. So there's a lot of different brands that make these pucks now, including Ivoclar, Avident, Baltic. There's many, many brands where you can have the denture teeth and the denture base milled from the same puck of resin. So that means with this type of denture, there are no separate denture teeth. The denture teeth and the denture base are polymerized at the same time. And that's really exciting to me. If you would prefer the look and strength and feel of a carded denture tooth, you can actually just mill the denture base and then bond in the carded denture teeth. So you can really customize these workflows and materials to meet your expectations. So I have a lot of colleagues that are very used to the look and feel of a carded denture tooth, but they want to capitalize on the benefits of the efficient workflow and the repeatability and the strength of the milled denture base. So if that sounds like you might be interested in this type of workflow that involves the milled CAD/CAM denture base with a carded denture teeth bonded into it. This is another view of that monolithic milled denture. So you can see when the puck is made, the denture tooth resin and the denture base resin are polymerized together. And then the software knows where those two lines meet, so you can get a really nice, very strong prosthesis. And again, we're avoiding that polymerization error. It's already happened when the puck was made. So now when we get that final denture fabricated, we have that nice fit. There has been many, many, many studies. So I showed you that slide from 2012. We've been working with milled polymethyl methacrylate dentures since 2012, meaning we have over 10 years of data, lots of systematic reviews, lots of reviews of the literature where we can start to see the benefits of that. So the current evidence base today shows that CAD/CAM milled dentures have a superior fit, mechanical properties, and physical properties to conventionally processed polymethyl methacrylate. So aside from subtractive manufacturing, the more exciting thing today is usually talking about additive manufacturing. This is more scalable for laboratories. So a lot of laboratories are moving forward and pushing forward the advancing 3D printing, and it's more affordable for clinicians. So it's a lot easier to get a printer in-house and fabricate prosthetics that way versus getting a nice 5-axis mill in-house and fabricating dentures that way. And so you can see here, I'll restart this video. We have a vat of resin. So this is a liquid uncured resin. And then there's a light that's a certain wavelength inside of the printer that's curing that. And so you can see this is curing layer by layer and fabricating this denture base. So you're taking this material, adding the layers one at a time and building it up that way. So it's additive manufacturing. I like to tell my dental students that this is very similar to the very first composite they do in first year dental school, where you do a teeny layer of composite and cure it, then you do a teeny layer of composite and cure it, then you do a teeny layer of composite and cure it to build the beautiful class 1 composite resin. The printer is doing that at a much finer level to fabricate whatever you're 3D printing. And this is showing you fabricate one thing at a time. So most vat printers allow you to print one shade of resin or one type of resin at a time. And so here you can print several denture bases on one plate, or you can print several arches of denture teeth on one plate. And then you take those two pieces and you bond them together. So with conventional vat printing, the teeth and the base are printed separately and then they're fused together, following manufacturer's protocols. So VJ was saying we've worked together for many, many, many years. The first commercially available printed dentures came out in 2017. So after it was FDA cleared, then they finalized the marketing. And so by the time we started seeding these, it was in 2017. And I would like to show you 4 of my cases that failed in 2017. And you can see I thought this was really exciting because we have a mixed failure here where we had kind of a debond and a fracture. We have a cohesive failure here in the middle where we have a fracture within the denture teeth. We have this fantastic debonding of a segment here, which I thought was really fascinating because in my mind, we're fusing this whole unit of teeth together so we don't have to worry about single teeth debonding because there are no single teeth. And then my patient showed me I was wrong because you can debond an entire segment of teeth. So this would be an adhesive failure. But one I think is really interesting is this one on the far right. This was an immediate denture that I delivered. And I had the patient come back for their 24-hour post-op consult. And this was what their denture looked like. And I was just astonished at the amount of stain that could accumulate in 24 hours for this patient's denture. And I like to show this partly as a historical context because none of these resins you will get today if you order a digital denture from a dental lab. But this is kind of the evolution. So these were the first generation of resins. We often refer to them as that now, which is first generation printed resins. The physical properties were not ideal. We saw a lot of failures. And so a lot of early adopters and people that were excited about 3D printing tried this out for you. So you're welcome. So that now we can have finally materials that are strong and beautiful and more like what we expect to provide for our patients. I will do an asterisk that every single one of those dentures I remade at no charge for my patients. So these are a set of dentures delivered back in 2022. So this was with the high impact printed resins. And what I think is really cool about this picture is if you look at the characterization in the denture with the stippling on the denture base and kind of the mamelons and that anatomy on the denture teeth, All of that was designed in the software. And so when it was 3D printed, it translated the stippling and the gingival effects, as well as the mamelons and the enamel effects, all came through during that 3D print. So we've really come a long way with not only the resins, but also the printing technology, as well as the design software. And certainly with the aesthetics of the denture teeth and the denture base. All right. Now in 2024, we started to see commercial release. This was released in 2024 at Lab Day, where we can start to see monolithic printed dentures. And so these are not that printer. So this is a different type of printer called filament printing or FDM or jetting printing. And so you can see here the denture base and the denture teeth were all 3D printed monolithically. And in this bottom photo where you can see all these dentures that are nested on the plate, what's really cool is that each one of these can be a different shade. So, and you can even print different shades of teeth on the same denture. So if you wanted to have like more bright teeth in the front or darker teeth in the back, or have characterization at the cervical and come down brighter at the incisal, you can do that with these printers. They function more like inkjet printers, where you can have like the cyan and the magenta and the blue, and they can all kind of blend together at that certain amount to get the shade you want. That's essentially what the filament's doing on these printers as they work. The downside is, since they are more novel, they're kind of at that early stage in their development. So even though they're starting to look very nice, they're working now on improving the strength and getting the high impact that you see with some of the current printed and milled resins today. And kind of piggybacking off of that statement, even within the VAT printers, not all printers and not all resins are created equal. And this was a study that we had done with our residents that we published in Journal of Prosthetic Dentistry. And you can see we have injection molding. So this is a conventional type of processing here, CNC milling, compression molding. So the one we were doing in 1937. And then these three are all different types of printers. And what we're looking at is the surface roughness. So how smooth is that resin when it comes off of the printer? And this one over here, totally different from the other two. And so because the formulation is different from printer to printer, we're not quite sure yet if it's the printer that's the issue, or the resin that's the issue, or the software that's the issue. So these are kind of the things that we're working through right now. As kind of a follow-up to that study, we looked under the scanning electron microscope at those resins. And you can see on the left, this printed resin looks really, really smooth. I'd be really confident with that material in my patient's mouth. But the one on the right is also a printed resin. And so you can start to see the variability from resin to resin with printing that we don't necessarily see with conventional processing or milling. With those technologies, we know what it's going to look like, whether it's very rough or not. It's consistent across the process. So to kind of wrap up 3D printing, these are two really lovely, comprehensive narrative reviews of the literature that both came out in the 2020s. And they both came to the same conclusion, both by two different prosthodontic groups at two different universities, saying that printing looks like it's the future. It's incredibly promising, but we don't yet have the evidence base to say that 3D printing is the same as milling or conventional techniques. So to summarize, we can certainly mix and match whatever we want. So you can have a printed denture base with milled denture teeth. You can have a milled denture base with carded denture teeth, or any combination of the above. So you can really mix and match the materials for whatever you believe in and whatever works within your practice to capitalize on those workflows for your patients. So that's kind of my quick and dirty. What is a digital denture? How do we get here? How did we get here? Where did we come from? And now that you have that foundation, let's roll into some of our workflows. I created this decision tree with some of my students and some of the companies I was working with to kind of help make things a little more clear. And I put a picture of a tree to be quite literal. And so what we're going to be looking at today will be kind of, where do you start? Does your patient have teeth? If they have teeth, we're going to start to look at different immediate denture workflows. If they don't have teeth, Do they come in with a denture or are they coming in with just gingiva? And each one of those steps will take you down this workflow to your definitive denture at the very end. So here we're going to start. Does your patient have teeth? We're going to work on the right side first, where if your patient comes in without teeth. And ultimately, we're looking at these types of patients that can come in. They might come in with a denture, whether it's good or bad. They might come in with no denture and just gingiva, or they might come in with a terminal dentition that we've now determined the next step in their dental career is going to be a conventional or complete denture. And for each of those patients, we're going to look at the reference denture workflow, the new denture workflow, and the immediate denture workflow. So I like to start with a reference denture because I feel like this, if you have not done digital dentures yet, and I know some of you have and some of you haven't, this is a really nice workflow to start with because the reference denture workflow for conventional dentures is very challenging. And anybody who's ever had a patient come in with a denture that they love and say they just want a copy of it and tried to make it conventionally a duplicate has suffered with me through this process. And even it made me feel better to read this manuscript from 1998. And this was a denture was sent to 12 different experienced dental technicians. And this was, and I don't think anybody here is from England, but this is a British dental journal. So if there's any lab techs that are offended, you can say maybe not American lab techs or Canadian lab techs or Saudi Arabian lab techs. This wouldn't be a problem. But it was a problem for me as a prosthodontist that used to make my own dentures. And it was a problem for these poor 12 laboratory technicians that received a conventional denture and tried to copy it. Of the 12 dentures, exactly 0 of them passed the test. So they missed at least one thing, either the extension of the denture, the diastema, the vertical dimension, or the horizontal relationship or the bilateral crossbite. And so once they evaluated all of these, they found that the dentures were not an acceptable match. Fortunately, we now have digital dentistry to help us overcome these conventional challenges that we have suffered for many years with our reference denture workflow. And the way we do this is by preserving the patient's records. So if you look at this image in the back, the purple is going to be what the patient came in with, their reference denture that gets scanned in. And then the white is where now your dental laboratory technician or you can start arranging digitally the denture teeth to perfectly match. So if your patient comes in with a denture, do you want to make changes? Sometimes your patient has a denture and they want to back up. Sometimes they have a denture and they love it so much they just want to duplicate that and maybe change the shade or something. Or they might come in and say, I like this denture, but it doesn't fit well anymore, or I've lost a bunch of weight, or I've worn the teeth down. And in that case, you're going to want to make changes. When you don't want to make changes and you're just copying the denture, that will be the copy denture workflow. If you are going to make changes, then you're going to follow the reference denture workflow. So we won't spend much time on the copy denture workflow because truly all you're doing is scanning the denture and telling the lab, make me a copy. So there's not much of a workflow there to review. The reference denture, on the other hand, is a little bit more nuanced. So the first step we're going to do is to actually look at the patient's denture. It might be good, or it might be bad, or it might be somewhere in the middle. And no matter where it lies on the spectrum of denture excellence, you can utilize that information to get further ahead with your next step. So we're going to look at the border extensions, check the intaglio fit, see how it adapts to the tissue. We're going to look at the occlusion, the vertical dimension, the centric relation, and last but not least, we'll look at the aesthetics. One thing I love to do is utilize the patient's existing prosthesis as a custom tray. I like to tell my students that this will probably fit better than any custom tray they're going to try to make from an alginate impression. So you can start with this patient's existing prosthesis and Usually they're coming with a denture that they like, or it might be the only denture they have. And so you don't want to do a lot of reversible changes to it if it's, or sorry, irreversible changes to it if it's not a denture that you made. So once you start adjusting it, then you have some sort of level of ownership for it. So we'll do irreversible changes at this very first records appointment while we're acquiring our data. So here you see on the left, we are painting some polyvinyl tray adhesive on the denture. This will be removed with alcohol on a gauze. So if you get some isopropyl alcohol and rub it on that denture adhesive, it'll come right off that denture. Then, if the denture is very underextended in any area, you can utilize a border molding material. Here we're using a heavy body polyvinyl siloxane. You could certainly use polyether, green stick compound, whatever. You can pick your poison of however you prefer to border mold your dentures. And then subsequently, you'll do a light body impression inside of that for your final impression. If your patient's denture fits pretty well, but you kind of want to snug up that retention or the stability, you can skip the border molding step with a heavy body and go just to the final impression step with a lighter viscosity material. After you do your impression, then you'll take your interocclusal record. So this record is where we're going to want to determine our vertical dimension and our horizontal relationship. And I think it's important to note that we're going to take the impression first, get everything to fit, and then do our interocclusal record. For all of these workflows, it's going to be the same. And I'd like to tell my students, because they take the crown class before the denture class, you would never adjust the occlusion on a crown before you made sure it was all the way against the tooth. You always make sure the crown is seated before you start adjusting the occlusion. You're going to do the same thing with a denture. You're going to want to do your wash impression, your soft reline, whatever you're doing to stabilize that denture first before you start messing with the occlusion. And again, after you do your impression to stabilize the denture, then we're going to take our full face photo for our orientation record. And again, you want the patient looking straight at the camera so you can see their eyes and can see their ears, and ideally smiling so that you can see the incisal edges of whatever they're coming in with, whether it's their terminal dentition or their existing denture. You'll also want to record any changes you want to make. So are we shifting the midline, lowering the incisal plane, raising the cervical, whatever it might be, and making sure you can visualize that on the photo you took. So to reiterate, and I'll say this a few times because I think it's so important, is to do your impressions inside the prosthesis before you do your records. So here we're measuring our vertical dimension after we've done our definitive impression. Once you've gotten all those records, so you've done your final impression as needed, you've taken your centric relation record, you've documented the aesthetic changes you want to make, and you've taken your photo, now you can start digitizing these records. And when you scan this little complex with the maxillary mandibular and the bite, now you have your final impressions, your interocclusal record, all of your aesthetic markings, your midline, incisal plane, occlusal plane, and that jaw relationship between the maxillary and mandibular. So now you can really move forward to designing a nice prosthesis. That denture design can be done by the clinician if you're very interested in the software side, or you can send those STLs to your laboratory technician and have them do it for you. So either way, you're going to be working the same software and moving forward in that workflow. A lot of times when people are getting started with a process, you'll start by delegating all of your designs to your dental laboratory technician. And this is going to be my public service announcement and one of my many soapboxes. As you can tell, I talk about this a lot. Please, please, please ask your dental technician for a digital preview before they go to the next step. The digital preview is basically showing that CAD design before it goes into the fabrication process. So this is kind of in between steps 2 and 3. And to me, this is really the way I've learned to communicate about dentures with my laboratory technician, is kind of taking screenshots and marking them up and communicating either remotely or asynchronously or however you want to communicate. But that digital preview is key to success for your cases. This is a lovely technique article out of Loma Linda that shows clinicians how you work through a digital preview. And this is basically what a digital preview is. you might just ask for some static images. And so in this case, I'll say I want an occlusal view, I want a lateral view, and I want a frontal view with the reference overlaid. And so in these images, the more translucent layer, so on this one, it's going to be the purple, and on this one, it's going to be the gray. So they're two different softwares. Those are our references. So this is the denture the patient came in with. And then the white, the more opacious, is the proposed tooth arrangement. So now we can start to see if the changes that I documented are actually implemented into the design. So in this case, I probably wanted to bring the occlusal plane back so that the patient had less lip support. This is really common with immediates going to the finals. It looks like they probably wanted a little more tooth display, so we lengthened those a little bit. If I had not wanted to move the teeth back and my laboratory sent me this image, I could say, whoa, 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 can we please kick those teeth back out? And now I've saved an entire appointment with my patient where the teeth wouldn't be in the correct position. Once you've approved that design, now we can go over to our monolithic try-in for a 3-appointment workflow. Or if you did really great records, your patient had a nice predictable CR, you can skip that monolithic try-in and go straight to final. So the reference denture workflow can either be a 2 or a 3-appointment workflow. I'm going to pretend like it's a 3-appointment workflow so that we can talk a little bit about what we have here for the monolithic trial denture. And I apologize that my video made it look like I just went on the moon. So I'm going to stop my video for a little bit so we can focus on the more important thing, which is monolithic try-ins. So here we have my new armamentarium as I've shifted from wax to resin. And here we're looking at where I'm most commonly going to live is with my E-cutter on my straight sleeve handpiece over here. So monolithic try-in or final for a 2 or 3-appointment workflow. And with the monolithic try-in, this is key to kind of overcoming those hurdles. So there's 2 real pain points in the digital workflow for those of us that were trained very conventionally. And the first is going to be that design aspect and kind of learning to work with a digital preview or the design software. And the second is going to be the monolithic try-in, because working with this is very, very different than working from a wax tooth try-in. But the cool thing is, with a wax tooth try-in, we're working with a triad denture base where we have a denture base that shrinks or may contract, and it doesn't quite have the same fit that you get with a final denture. With a printed monolithic try-in or a milled monolithic try-in, this denture base is actually the design of the final denture base. And to me, this is so exciting because one of the scariest things to me about delivering a conventional denture is at that seat appointment, where you seat the maxillary denture, you kind of seat it and you feel that suction, and then you step away and you tell the patient to smile. And I always pray that when they smile, that denture stays in their mouth and doesn't drop onto their lap. With digital, I know if the patient is going to have a denture that fits at that final appointment because I've already tried in the denture base at this monolithic try-in appointment. And so you can see on the left-hand side, in this case, it was overextended on the flanges. So I was able to use PIP to see where those overextensions were and adjust those before we go to the final. On the right-hand side, this monolithic try-in was not retentive. So we didn't quite get what we needed in that final impression. And so in this case, I do a wash impression inside that monolithic try-in before we go to the next step. So here we're adjusting the fit of our prosthesis and making sure that we want that monolithic try-in to fit exactly like our final denture. Next, we're going to verify our aesthetics, and you can do that very easily with a Sharpie. So if you want to make some changes here, you can just kind of mark these, take a photo, send it back to your lab. So now they have a reference of what you're seeing. I encourage you to take a photo with a Sharpie marks like we've done here if you're going to do it this way. Otherwise, if you want to have a little more fun, you can actually carve onto that monolithic try-in where you want everything. And so I love to actually take a 6 round and carve where I want my cervical margin and shave down to where I want my incisal edge, so we can try that out chair side before I send it back to the lab. Next, we want to make sure our vertical, horizontal, centric relation and everything interdigitates in the occlusion. And I love to show this photo because you can see I'm using my fattest burr, and I am grinding these teeth down with reckless abandon. So you can see all the white powder on my gloves and on the tray table. I'm not being very gentle like I would with a wax tooth try-in. I'm being very bold because this is more like a wax rim. So when the occlusion's high, I get rid of all those interferences so I can allow my patient to be seated in centric relation at the correct vertical dimension. If you have not worked a lot with monolithic try-ins, or if you're training a new assistant to help you work with monolithic try-ins, I really strongly recommend checking out this checklist on the Dentsply Sirona website. It's free. And you can basically go step by step. They're all yes or no questions on, does the denture fit? Yes or no. Is it overextended? Yes or no. And it kind of tells you what to do at each of those steps to get through that try-in process. And once you've gotten through this, then it becomes a lot more comfortable. And then someday you'll be like me, where you don't want to see a wax tooth try-in ever again because the monolithic has so many different benefits and it's so much easier to work with. My last public service announcement about monolithic try-ins is going to be, when it's way off, treat it like a wax rim. And these are two real life cases from the dental student clinic here, where in this case we overestimated our lip length, and so our denture was about 5 millimeters too long with our tooth display. So instead of marking with a Sharpie here, I took an E-cutter and flattened these incisal edges down to where I wanted my incisor display to be. And then here I took a 6 round burr and actually carved where the high smile line was because I didn't want the patient to show a lot of gingiva. So now we can start to see what kind of denture we might get in the next monolithic step. The one on the right is one that one of my colleagues did, and he heard me say treat it like a wax rim and took me very literally and took this monolithic try-in to actually the lathe, the model trimmer, and flattened it out like a wax rim and then cut notches in it like a wax rim. So you can see when those monolithic try-ins don't fit, don't be shy and don't treat them like a wax tooth try-in. Treat it like a wax rim and be bold. So I want you to think of me the next time you have a monolithic that doesn't fit and you're hesitant to grind on it. Get over it and just go for it with that big fat E-cutter. All right, so again, these are just kind of reiterating our goals for any try-in, whether it's conventional denture, even veneers, anything you're going to want to verify your centric, verify your vertical, verify your aesthetics, and verify your phonetics. All right, so 3-appointment workflow if you do a monolithic, 2-appointment workflow if you go from records to final. If you have not done the reference denture workflow, if you're training a new assistant or training an associate, if you snap this QR code, this will take you to a YouTube video on the Dentsply Sirona website where I actually walk through, me and my colleague and I did a series, did these 2 videos for Dentsply Sirona. So one is her and one is me, where we walk through the reference denture workflow and the wax rim workflow. Okie doke. So now you kind of get the gist of how you're going to get from A to Z with digital dentures. So let's say your patient is on the decision tree where they come in without a denture or teeth. So this will be our new denture workflow. In these cases, the most straightforward thing to do is to start with a wax rim. And you can certainly fabricate that conventionally. If you have a dental assistant that's comfortable with this, that's phenomenal. Where you have them take an impression, pour an alginate, or pour it in stone, and then make a wax rim with light cured resin and a record base and a wax rim. Or you can scan and 3D print your record base, which I think is arguably more fun. So, and this is just working on Blender software or Mesh Mixer. You can scan it and design it, or you can scan it and send it to Row, and they will 3D print a record base or a custom tray for you. So here I just printed it in Tar Heel Carolina blue and added a wax rim to that. In the wax rim workflow, we're going to utilize those trays to make our maxillary and mandibular final impressions very, very similar to the reference denture workflow. But now that these are stabilized, we do the impressions first, then we do our tooth position or occlusion. We're going to start contouring that wax rim. And you can see here we have our canine lines marked, our midline marked, our high smile marked. We've set our vertical dimension of occlusion, set our centric relation, and recorded that with a bite registration material. Ideally, at this point, you would also take a full face photo with that wax rim in place where you can see the lines that you marked, and then you can go into a digital smile design from there. In addition, we'll scan those records the same way we would scan any records. Could be the benchtop scanner like you see here, could be the intraoral scanner, or it could be a CBCT scanner, and export that STL. And this makes me really happy to see that when you scan your wax rim, you can actually see the markings you made. So your high smile line, your midline, and your canine lines are all preserved for all of eternity. In the conventional denture workflow, the first thing we would do would be to melt this away and put the denture teeth on and eliminate all those landmarks. But here we maintain those landmarks throughout the whole process. And if you had taken a full face photo here, these landmarks are how you would merge the photo to the scan. And the other thing I like to show is when you remove that wax rim from the design, you can see our virtual master cast. And you can actually see that the software puts on a land area. So it preserves all of that anatomy you took in your scan without having to go through the process of box and pouring to preserve it in that respect. Once you have everything scanned in, you'll go through a cast analysis and then utilize a CAD software to arrange your teeth. Typically with a cast analysis, you pick the landmarks. Usually it's tuberosity, incisive papilla, retromolar pad, the midline on the mandibular arch, and then the software will go through its algorithm and auto-populate teeth into your arch. It's really cool because when you're arranging wax teeth, you have to move each tooth individually, and sometimes the wax will get hot and shift everything else. Here with the AI software, you can click the whole arch. You can drag the whole arch forward and backward and up and down while maintaining that vertical. You can just move the posterior teeth, just move the anterior teeth. You can resize the teeth. So if you want a bigger central and a smaller lateral to replicate what your patient had pre-op, you can do that in a way without having to buy 17 cards of denture teeth. And you can superimpose your reference. So that digital preview will show where everything interrelates. So if you look here at the lower left, this would be where I ask my laboratory to send me a digital preview overlaying with my wax rim, because I marked my midline and my high smile line on my wax rim, and I contoured that rim so my incisal edge is in the right position. So now when I look at this, I can see if the lab followed my instructions and put the incisors where I contoured my rim, if the midline's in the midline, et cetera, et cetera. So the next step that we're going to go here, if you did a really nice record, if you got a full face photo, if everything aligned really well, you can go from that wax rim directly to your final denture, or you could go to a monolithic try-in. So you can start to see the pattern. The monolithic try-in is an optional step if you want to get that extra verification, if you want your patient to take it for a test drive, if they've been through a series of dentures where they want to make sure that everything is verified before they go to final, you can choose that optional try-in appointment. Or if they're in a hurry, or if they're just ready to get some teeth, or if they're leaving town, or if they're going to a wedding, you can go directly to that definitive denture and bypass that try-in. This is another YouTube video on the Dentsply Sirona website. So if you're interested in seeing that wax room workflow in action, you can grab a screenshot here and this will take you there. If you miss any of these links, I shared my slides with Ro, and I'm sure they'd be happy to get everything to you. Or you can send me an email directly and I'm happy to share them with you as well. There are also proprietary workflows you can use if your patient comes in without a denture and just gums. This is an example of one called Good Fit, where they're basically thermoplastic monolithic try-ins. So I say you can do the reference denture workflow even if you don't have a reference denture. And so in this case, you measure the arch and find the one that fits best. You can mold it in hot water and try to adapt it to your patient. Typically, you'll end up doing some sort of reline impression. I like to use with printed materials. I really like these silicone relines. And then we take our CR record at the correct vertical. Now we're basically on the reference denture workflow. So your patient comes in with nothing. You have some good fit trays or some other proprietary trays in hand. You can now go to a final denture at appointment 2 or do a monolithic try-in and go to appointment 3. I love next to talk about the immediate denture workflow. Everybody who loves dentures probably has a love-hate relationship with the immediate denture. I know that I used to live in that world where I loved making dentures, but I got so stressed out with immediate dentures. So these are for the patients that come in with a terminal dentition, and we're going to remove the teeth and seat the immediate denture at the extraction appointment the same day. Immediate dentures come in two different flavors. The first is going to be a conventional or classic immediate. That's going to be your definitive prosthesis that they wear forever, and you do a laboratory reline after a 3 to 6 month healing period. You could also do an interim denture or transitional denture, and this is where I live now, where you treatment plan phase 2 to remake the denture. So the main difference between these two is going to be kind of what's phase 2 of the treatment plan. Are we making the final denture to be delivered and then doing a hard reline, or are we making an interim denture that we intend to remake after the patient heals? Because I've had so much experience where the immediate dentures didn't turn out the way I wanted them to, I've lived now in this interim or transitional zone. If you're going to do your definitive classic immediate, and then you're going to want to make sure you take a lot of steps. This was how I learned how to make immediate dentures when I was in dental school, and probably you too, where you make a custom tray, you still border mold, do your wax rim, do your partial tooth try-in, verify your centric, make your surgical guide, and your definitive denture. So lots of laboratory steps, each one with room for error. And the thing that stressed me out the most was, for all of you that asked, which is nobody, with immediate dentures, you get your records, you take your definitive impressions, you mount your casts, and now you're ready to arrange your denture teeth. And so the first thing we're going to do is cut off 9 through 11 and arrange those denture teeth to match the adjacent side. The next thing we're going to do is grind off the rest of our references. So once you've taken all the denture teeth off the cast, you now have no more reference of where the patient's existing teeth were. And I've tried to do this with putty. I've tried to do this with bite registration. It's impossible to really replicate where those patients' teeth are. And this case particularly stresses me out because you can see there are two midlines marked, and I don't know which one is the real midline and which one is the imposter. The other story that has changed me forever, BJ mentioned that we met each other when I was practicing in Atlanta. Beautiful practice. It was on the 8th floor of a high rise in downtown Atlanta. The lab had windows around the whole thing. It was the most relaxing, beautiful place in the world, that dental lab. And I was a prosthodontist. I am a prosthodontist. So I like to arrange all my own denture teeth, sitting in the sun, enjoying the beautiful fall weather, the summer weather, and just feeling great while I arrange these denture teeth. One day, I arranged my immediate denture teeth, left the articulator on Friday afternoon, and the power went out over that summer weekend. And so when I came in Monday morning, my denture teeth were not in the same spot that I left them on Friday afternoon. And I had no way to reorient those teeth to the original pre-extraction casts. So to me, this is very risky. You're losing all our data. The landmarks are obliterated. With digital workflows, as you've seen, everything we scan in lives there forever, from your wax rim to the midline you marked to the patient's pre-op casts. So now we can use a CAD design following the patient's existing dentition. And when I get those digital previews back, I can see that Row Dental Lab has put 8 and 9 on my CAD design exactly where my patients 8 and 9 are today. Because that overlay shows me that we're not having that risk of the patient's teeth being too far out or too high up or too much gingival display. So we've now greatly improved that predictability. If you want to take a screenshot, or we can share the slides. This is my interim or immediate denture workflow and kind of how we decide where to go. But step 1, as always, is acquisition of data. Typically for immediate, we're going to use an intraoral scan. We have a lot of teeth there, so it's a lot easier to capture the data than just the soft tissue. And my patients always come in. I like to show this slide. I had 3 gentlemen come in a row that had very similar whiskers, and they all needed immediate dentures. So when these people come in, we're going to measure their vertical dimension, get their aesthetics, but each of them is going to be treated a little differently. So for this patient, we decided to do a combined digital conventional workflow. He had an existing RPD on the top that he liked the look of the teeth. You see there's a few little things. We're going to shift the midline, correct some incisal canting, and of course, replace the missing teeth. So here we did conventional impressions and actually made a conventional wax rim. And so now we have mounted physical models in centric relation at the correct vertical that we can send to the lab. And if you are doing conventional records, you want to make sure that you obtain a tripod. So I always tell my students, if you need to know when you need to do a wax rim, it's when you're missing one leg of your three-legged table. You need to have a posterior stop on each side and an anterior stop in the front, and that gives you that stability to mount that cast. If you're missing any of those stable stops, you're going to need to use a wax rim to replace that missing data. And that's not the case if you're using a scan, but if you're using conventional workflows, you want to make sure you use a wax rim to mount your casts. All of that now got scanned in. So I send the lab my master cast, I send them my wax rim, and they scan everything in, and now we can do our digital smile design. So we send full face photo and all of the physical records that get scanned in. So now we can take the patient's existing dentition and start to see what would happen if we lengthen the teeth or if we shift the midline or whatever goals we want to achieve. And with that full face photo, you can do a digital smile design for dentures the same way you would for your implant cases or some of your other aesthetic cases. So this is showing that digital preview without the partial so that we can see where the soft tissue aligns, where the midline's aligning, and where our records are. In this case, we did a partial monolithic try-in. So whenever my patients are missing a lot of anterior teeth or a lot of posterior teeth, I like to do a partial monolithic try-in to kind of verify aesthetics and occlusion. And then from there, we can now go to fabrication. This is a case that we did with my colleague, Ibrahim Dukam. We have a 3D printed denture base, carded denture teeth, and this is the day of insertion. And if you're interested, this will take you to I think it was a Lab Management Today article. You do have to create a free account if you want to look at it, but that will take you to that website. So you can bypass the conventional records and do a purely digital workflow. And I think this is becoming more and more common for immediate dentures. So this is one of my other patients with whiskers that came in and needed an immediate denture. And so in his case, we did intraoral scans of the maxillary and mandibular, and then I did a scan in centric relation at the correct vertical to capture his jaw relation record. And with the scanner, you don't have to use a wax rim if you can stabilize the patient's bite some other way with a Lucia jig or a leaf gauge, or a partial denture or whatever they might have, because the scanner can lock in this relationship without the rim. So if we're going with a fully digital workflow, we want to get our intraoral scan, our full face photo. We use that full face photo to do a digital face bow, and then our occlusal record. And this is just an article, if you're interested, at JPD that shows how to do that in Exicad. And kind of the key for this step is when you're restoring your patient in centric relation, which will be the case for all of your complete denture patients, you want to do your scan in centric relation. And so this is my colleague doing a CR scan on me. And basically you keep the patient at that open bite and you scan with the teeth separated at the correct vertical and centric. And the scanner will actually merge the two scans together and maintain that vertical relationship for when you send that to your dental lab. So here you can see we have an open bite, and the lab can preserve that when they make their immediate dentures. And this is the digital preview that I got back from my lab. So you can see we wanted to open the vertical. We also wanted to shorten the central incisor and raise the occlusal plane. So we're planning some alveoloplasty here. And then this is the insertion of that immediate denture. As there's a retractive view, this was actually one of the monolithic printed dentures with the jetting technology. And no matter what you do, you have to border mold somewhere. So you saw me start with a scan. I didn't start with a border mold and impression. With immediate dentures, the border molding usually happens at the soft reline. So now we're making up for that lack of border molding when we do our soft reline at that insertion appointment. And this is probably the number 2 most common question I get is, can I reline my printed denture? And the answer is yes. You can reline any denture material. The main key is to get it very, very, very dry. And I don't mean using air water syringe dry. I wipe it with alcohol on a 2x2 and desiccate that. Then I dry it with the air water, and then I dry it with another 2x2. So it is bone dry. And then you can treat it with whatever material you're using for your soft reline. Typically with printed materials, the silicone relines tend to stick a little bit better, but I have relined all these printed dentures with Co-Soft, Co-Comfort, Linol, and the silicone resins and the new Hydrocast, whatever that one's called. They all stick to this printed resin very well if you get it dry. This is walking through the digital immediate denture workflow. If you'd like to see that step by step, again, you'll have to probably create a free account with Dentistry today, but this will walk through my digital immediate case. So now digital dentures are not, or immediate dentures are not as scary anymore because we have that predictability of digital dentistry, where I know the teeth are going to be exactly where I want them to be. I know I can reline them, and I'm very happy with my fit and my predictability. We'll finish up here with implant overdentures and just show how you can incorporate digital into those. The majority of implant overdentures today are on locators, and typically those are implant retained but soft tissue supported. When you do 2 locators in the anterior mandible, the back of the denture is still supported by the gingiva and the bone. So what that means is you still have to make a beautiful denture with soft tissue support before you place the implants or load the implants. And this is just a nice quote that you can't take a bad denture, put 2 implants in it, and make it a good denture. It's still a bad denture, but just with implants. So you want to make sure you have a nice, well-fitting denture when you load those implants. So sometimes you already have implants placed, and then you're going to make your denture. And so in this case, and this was another one with my colleague, Ibrahim Dukam, you can go ahead with your border molding steps. You can see where the locators are here. Then you do your digital preview from your dental laboratory, and you can see they have designed this space for the locator housings that's built into the software, the diameter of the housing. And then when you get your definitive denture back, you already have the wells made, which is something that's harder to do with conventional processing. Sometimes you have you make your denture first and then plan your implant placement. So this will be one of my more challenging cases that I saw. Very sweet patient with microstomia, difficulty opening. I felt very bold and decided to try to scan. And if you cannot see the landmarks on these scans, neither could I, nor could my dental laboratory technician. So I said I chalked this one up to experience and decided to use a compound tray to try to contour down to where my patient is. So we ended up doing a physical impression. And I did print those models to kind of help guide me with my initial tray reduction. And I like to show this photo because the trays on the bottom are the trays that I actually contoured in my patient's mouth. And above that, I sat next to it an unmodified tray. So you can see the size discrepancy as we go from the stock tray to my customized stock tray. Border molded final impression, gets scanned into the software. I did kind of a partial wax tooth printed try-in and use that to get my records for my monolithic trial denture. And so in this situation, I was trying to make sure I could get the dentures seated in the patient's mouth. At this point, we did a dual scan CBCT. This was the conventional dual scan with the fiduciary markers. For implant planning. In my wildest dreams, this would have been guided surgery, but as you saw, my patient couldn't open very wide. You need 45 millimeters of opening from the opposing to the opposing occlusal table for guided surgery, so we ended up just duplicating the denture. I used a monolithic try-in with some holes in it for my surgeon to place those dental implants. So no matter how you place your implants, the implant overdentures are more likely to have complications than complete dentures because you have to have room for the housings or the bar or the framework. Now we have improved monolithic materials to help decrease those risks. You can utilize just a monolithic milled denture to capitalize on the strength of resin, or you can incorporate a metal framework like you can see down here to help decrease some of those fracture risks. So whenever I have a patient that's very limited, I try to incorporate a metal frame to help eliminate some of that. And so this is this is the patient with a limited opening. We made locator overdentures, maxillary and mandibular with these embedded titanium frameworks. This is her final. The smile is fine, but what I loved was that she was able to close her mouth because it was really a challenge to get everything worked through here. So to kind of summarize digital dentures, we are working on enhanced material properties. We're saving every record from the impression to the jaw relation to the tooth try-in, improving laboratory communication with a digital preview, and consolidating those steps for a more condensed workflow, start to finish. So thank you for your time and attention, and we have just under 10 minutes to answer some questions.